Now, let's write some Python code for building a small graph. So here we are going to build a small healthcare claim graph using NetworkX. And we will also visualize it and use centrality measures to identify the suspicious nodes. So this is a beginner friendly, and it's going to be the exact foundation of what we are going to build in the next coming episodes. So in the first two steps, we are creating our graph. We initialize a directed graph, directed because claims flows from patients to providers. And we are adding three patient nodes here and two provider nodes, right? P1, P2, P3, and two provider nodes, PR1 and PR2. We then add edges representing the claims that P1, P2, P3 all file claims to PR1, while P1 also files to PR2. In step 3, we visualize the graph and compute the degree centrality, a measure of how many connections each node has related to the total possible. So, with the degree centrality measures, we can get what is the suspicious pattern that we can find. It's a very simple node structure. So this is the graph it looks like, where you can see that the PR1, the provider 1 has the highest the degree centrality score because P1 is connected to both PR1 and PR2, and PR1 is also connected to the patient 2 and patient 3 as well, right? So when we print the results, look at like what I have shown here. So this is dramatically higher than PR2, like provider 2, which is 0.25. What does that mean? PR1 is the hub. 3 out of 3 patients in this smaller network are connected to it. In a real graph with thousands of nodes, a provider disproportionately high centrality is your first hand signal, fraud signal, and the code just found it automatically. So let's see in the next coming episodes of how we are going to build this kind of graphs. It is scalable using like PyTorch, geometric, or any other things that we can do. So we can try that in the next coming episodes. Thank you.